We're going to talk about how to write an exponential model given two data points. First step, if one of the data points has the form 0a, then a is the initial value. Yay, that'd be really helpful if that happened. Doesn't always happen. Using a, substitute the second point into the equation f of x equals a b to the x and solve for b. If neither of the data points has the form 0a, meaning it's a y-intercept, substitute both points into the equation in the form f of x equals a b to the x and solve the resulting system of two equations and two unknowns to find a and b. Using a and b found in steps above, rewrite the exponential equation f of x equals a b to the x. So in this problem, it says 80 deer were introduced into a wildlife refuge. So 80 deer that is introduced, that's going to be our starting point, is that we have 0, 80. So yay, we have our A. By 2012, so this is from 2006 to 2012, so our time in that is 6 years. So after 6 years, we have 180 deer. Write an algebraic function, n of t, that represents the population, n for number of deer, over time t. So we have n of t equals a b to the t, and that's going to be 80 times b to the t. So now we can take the other point, 180 and 6. So 180 replaces the number, equals 80 times b to the 6th power. We can divide both sides by 80. So 80 over 180 reduces to be 9 over 4 equals b to the 6th. So now we could do the 6th root of b to the 6th equals the 6th root of 9 over 4. I'm going to go with just the positive because even though even index we can go plus or minus, it wouldn't make sense to have a negative, or a negative would be decreasing. But so anyway, this in this problem here, b has to be positive. So I guess it's between 0 and 1 is decreasing, but it's you wouldn't have a negative b. So I may have misspoken there. So b equals, and taking the 6th root, we have 1.1447. So our function n of t is going to be 80 times 1.1447 to the t power. Hope you can see that all. Okay. Let's look at example 4 now. So example 4 says find an exponential function that passes through. Now this one we don't have the y-intercept. So it passes through these 2 points. So we can just write this as f of x equals a b to the x. So in the first case we have, so this is the f of x, that's going to be the x. So we have 6 equals a times b to the negative 2. And then we have, in the second case, 1 equals a times b to the 2. So we have to basically solve and substitute. So let's take a look at this. What if we multiplied this one by b to the 2 and b to the 2? That allows us this part to cancel. So we'd have a equals 6b squared. Then I can take this expression and put it in place of a in that second equation. So 1 equals, instead of a, we're going to put 6b squared times b squared. So 1 equals 6b to the 4th power. And I can divide both sides by 6. So b to the 4th is 1/6. And then b to the 4th, I'll take the 4th root, equals the 4th root of 1/6. And b would equal approximately 0.6389. So our function, oh, we're not done yet. We have to find a. And we said earlier a was equal to 6b squared, so it's going to be approximately 6 times 0.6389 squared, which gives us 2.4492. So our function f of x is going to be 2.4492 times 0.6389 to the x power. That's one not as pretty, but that's the process.